Hi, Assalamualaikum and hello to Dr. Arif. We are from Group 1, consists of me, Ahmad Afif Jazimin, Ling Kai Peng, Lau Jiru and Muhammad Nazri, of course, Thermodynamics and Mechanics of Material Laboratory. So today we are want to present our experiment 5, which is bending moment. The first part is introduction. The objective of this experiment to measure the bending moment of material when subjected to different loads at different distance. The scope of this experiment, the first one, for a simply supported beam, the bending moment at the ends will always be equal to zero. Number two, the bending moment at any point along the beam is equal to the area under the shear force diagram up to that point. Number three, if a shear force produces a clockwise moment, it will be a positive value, while anti-clockwise it will be a negative value. And the last one, the loads ranging from 10 Newton to 20 Newton and the distance between load hanger P1 with load hanger P2 and load hanger P2 with load hanger P3 varies in this experiment.
I will present about the theory. A bending moment is the reaction induced in a structural element when an external force or a moment is applied to the element, which causing the element to bend. In general, bending moment equals to vertical net force applied to the element multiplied by the distance from the point. In the case where slung spring balance present, bending moment equals to spring balance multiplied by the level of. We will refer to figure 1, which is a simply supported beam with a distributed load to see how to calculate bending moment. We assume that the bending point is x. So first, we will calculate equilibrium of moments for part A of the beam. Bending moment at x equals to moment at point A multiplied by distance from point A to bending point from the left. Then we will calculate the equilibriums of moment for part B of the beam. Moment at point x equals to moment at point B times distance from point B to bending point from the right minus by the lock point times the distance between the bending point and the lock point. Hence, the bending moment at x equals to the moment of the lock point minus by distance from point B to bending moment from the right times moment at point A, which in the end is moment at point A multiplied by distance from point A to bending point from the left.
So this is our experimental setup. As we can see in the figure 1, we have point A, point B and point C. Then we have beam support at A, which is RA, and beam support at B, RB. And then we have a load hanger 1 P1, load hanger 2 P2 and load hanger 3 P3 to set the loads. And the last one, we have a slung spring balance that adjusted at lever arm of 150 millimeters.
Part 1. Effect of different loads for P1, P2 and P3 on the beam. First step. The beam support RA was being set at point A and the beam support RB was being set 900 millimeters away from point A. Step 2. The load hanger at P1 was being set 200 millimeter away from the fixed hanger P2 and the load hanger at P3 was being set 300 millimeters away from the fixed hanger P2. Step 3. Part A and B of the beam were being aligned by adjusting the spring balance until the bubble in the balance was at the center. Step 4. The initial reading on the spring balance for the balance reading when the load was 0 Newton was recorded in table 1. Step 5. 10 Newton of load was being placed on the load hanger P1. The beam was being realigned and the reading of the spring balance was recorded in table 1. The 10 load was being removed from the load hanger P1. Step 7. Steps 5 and 6 were being repeated for the fixed hanger P2 and the load hanger P3. Step 8. 20 Newton of load was being placed on the load hanger P1. The beam was being realigned and the reading of the spring balance was recorded in table 1. Step 9. The 20 Newton load was removed from the load hanger P1. Step 10. Steps 8 and 9 were repeated for the fixed hanger P2 and the load hanger P3. Part 2. Effect of different positions for P1, P2 and P3 on the beam. Step 1. The beam support RA was being set at point A and the beam support B was being set at 900 millimeters away from point A. Step 2. The load hanger at P1 was being set 200 millimeters away from the fixed hanger P2 and the load hanger at P3 was being set 400 millimeters away from the fixed hanger P2. Step 3. Part A and B of the beam were being aligned by adjusting the spring balance until the bubble in the balance was at the center. Step 4. The initial reading on the spring balance for the balance reading when the load was 0 Newton was being recorded in table 2. Step 5. 10 Newton of load was being placed on the load hanger P1 and the load hanger P3 and 5 Newton of load on hanger P2. The beam was being realigned and the reading of the spring balance was being recorded in table 2. All loads were removed. Step 7. 6 Newton of load was placed on the load hanger P1, 12 Newton of load on the load hanger P3. The beam was realigned and the reading of the spring balance was recorded in table 2. Step 8. 2 Newton of load was placed on the load hanger P1 while 10 Newton of load was placed on fixed hanger P2 and 6 Newton of load was being placed on the load hanger P3. The beam was then realigned and the reading of spring balance was recorded.
This is the data we recorded for Part 1 experiment, where the measure and theoretical bending moment are calculated. This is the data we recorded for Part 2 experiment. Same like before, the measure and theoretical bending moment are calculated. Now we will begin the discussion for Part 1 experiment. Now I will show an example on how to calculate the measured bending moment by taking the reading for P1 with 10 Newton and apply the formula spring balance times lever arm to obtain the bending moment. From the experiment, we know that when the load at P1 is 0, the spring balance reading is 20 Newton. When the load at P1 is 10 Newton, the spring balance reading is 24 Newton. Given that the lever arm is 150 mm, which is constant throughout the experiment, we can find the measured bending moment by multiplying the net force with the lever arm. Hence, the measured bending moment is equals to 600 Newton millimeter. The following calculation for measured bending moment for load equals to 20 Newton, P2 and P3 are the same. Now I will show the examples to obtain the theoretical bending moment. We will use the graphical method to find the bending moment at point C. Here are the steps to do the graphical method. First, we find the reaction forces at point A and B. Next, we draw a graph of force against distance. Lastly, we determine the bending moment by finding the area under graph. From the calculation, we can see that reaction at B is equals to 1.111 Newton and reaction at A is 8.888 Newton. This is how the graphs will look like. On the top, we have the graph of force against distance. At the bottom, we have bending moment against distance. The part where shaded with blue is the area under graph. In other words, it is the bending moment. You may pause the video to go through the graphs. Here is the example of obtaining the theoretical bending moment at P2 with 10 Newton load. The same solving method like previously, you may pause the video to go through the calculation. Here is the example of obtaining the theoretical bending moment at P3 with 10 Newton load as well. Again, the same solving method, you may pause the video to go through the calculation. Before I proceed to the next part, I would like to inform that the theoretical bending moment for 20 Newton loads will apply the same solving method as well, just that the values are changing. Hence, there will be no examples on the theoretical bending moment with 20 Newton loads in this video. Now we will proceed to the discussions for part 2 experiment. Before I begin, I would like to inform that the calculation for measure bending moment are the same like part 1. By taking the net force multiplying with the lever arm, we can obtain the measure bending moment. Now I will show the calculation for obtaining the theoretical bending moment. The same steps and objective, we apply graphical method to obtain the bending moment at point C. You may pause the video to go through the calculation. Same like before, the graph on the top is the graph of force against the distance. The graph at the bottom is the graph of bending moment against distance. You may pause the video to go through the graphs. Here is the calculation to obtain the bending moment at C when P1 equals to P3 equals to 10 Newton and P2 equals to 5 Newton. Here is the calculation to obtain the bending moment at C when P1 equals to 6 Newton and P3 equals to 12 Newton. Lastly, here is the calculation to obtain the bending moment at C when P1 equals to 2 Newton, P2 equals to 10 Newton, and P3 equals to 6 Newton. Based on the finding, here are 5 observations we can say. First, the bending moment will increase when the load is placed right at the point where bending moment is measured. The bending moment is reduced when the load is placed further apart from the bending moment point. When the load increases, the bending moment increases. When the load are applied at the both end of the beam, the bending moment is higher than one load applied at the bending moment point. The bending moment increases when the load at the bending moment point increases.
The graphical method is used to obtain the theoretical bending moment in this experiment. From the comparison between the experimental and theoretical bending moments, the largest difference between them is around 400 Newton millimeter. Hence, we are able to determine the relationship between experimental and theoretical bending moments of material when subjected to different loads at different distance. From this experiment, we could learn that the bending moment increases when, firstly, the load increases, secondly, the load is placed right at the point where bending moment is measured.
Safety procedures. Number 1. Personal protective equipment (PPE). Wear appropriate PPE such as lab coat and closed-toe shoe to prevent potential that might cause loads falling. Number 2. Handle the apparatus carefully. Avoid to put hands directly under the load hanger while it is being loaded and when adjusting the load to prevent any accident. And number 3, report any injury. Report to lab assistant to get the first aid treatment if there is any injury happens. This is our reference throughout this experiment.
This is our appendix, which are the data obtained during the experiment. Thank you for watching.